Hello, everyone, and welcome. Thank you for joining us for our webinar today. We're going to be talking about measuring the benefits of your optimized images. There's been lots of talks about optimizing images, lots of talks about measuring the performance of web applications. This webinar is going to be unique in that we're bringing both of these topics together. My name is Rob Holcomb. I lead a team of solutions engineers here at Optimize, and we're focused on improving web performance for our customers using tools like Impulse and Image Manager. I'm going to be your host and moderator for today's webinar, and we'll be keeping an eye on the questions as they come in. Just a couple of housekeeping items before we get started. We are recording this session, so you will have access to this afterwards for not only yourself, but any colleagues you might want to share this webinar with. We do highly encourage questions. I know both of our primary presenters would be very excited to get your questions, so please keep those coming as we go through this session. We will address them at the end, not throughout, so once the primary content is complete, we will get to your questions, but please submit those as we go through. As you know, the best and most engaging websites are those that have lots of great-looking, high-resolution images. However, in order to balance the quality of that experience and ultimately the performance your users experience, we try to optimize those images. This can be difficult, though, because to do it properly requires multiple formats and sizes of images. And it can be harder still then to measure the benefit of these optimizations as well. So as part of our talk today, we're going to share a recent optimization story and use case. We're also going to talk about some best practices to make sure you see the best return on investment from your image optimization efforts. As we go through this webinar, I'd like you to think about how you measure performance today and whether or not you're measuring the right way. And at the end of this session, we will discuss best practices to navigate some common issues when measuring performance improvements. With that, I want to introduce our primary presenters today. I'm extremely thrilled to have two performance experts with us on the line here today. Every time I talk to these guys, I learn something new, and they're just absolutely experts in this space. So I think you're going to learn a lot here as we go through the content. First, we have Simon has joined us today. He is a principal engineer on the Impulse visualization team, data visualization team. He's responsible for some of the truly differentiated analytic visualizations that we have inside of Impulse. He's worked in web performance for well over 5 years in a range of pre-sales, consultancy, and engineering roles. He's passionate about data visualization. In fact, for those of you who are familiar with web page test, he built the performance map plugin that visualizes third parties. So if you've seen that, that's pretty cool. And he's also the host for the Delta V Web Performance Conference in London. Michael Gooding currently heads up a performance team here at Optimize that specializes in helping customers with front-end performance challenges. He's worked in web performance as a front-end consultant for over 7 years. And over the last 2 years, he's been really focused and deeply immersed in the world of image optimization. So with that as a reminder, as we get into the content here, we are taking questions, so make sure you enter those in the Q&A box. And with that, I think I've sufficiently inflated Simon and Michael's egos, so I'll turn it over to Michael to get us started.
Thank you, Rob. So let's kick off then with optimizing the images, and let's introduce you to the customer of this, like the main centerpiece of this story. This was a UK retailer with a strong online presence. If you look at their website, it's pretty typical of a normal commerce website. They have a homepage with big banner images in a carousel. There's large images on the category pages. There's product listing pages with many smaller, more like thumbnail images. And then when you get down to their product pages, you've got the typical large zoom images as well.
And their site is typical in more ways than one. If you've been to any performance conferences in the last few years, you will have noticed a lot of people talking about image weight being the biggest culprit for slow websites. When we look at their homepage, we see that 75% of the transmitted bytes come from imagery, which means only 25% is coming from CSS, fonts, JavaScript, HTML, all those interesting things to make a website work. Now, we looked at the homepage both on desktop and mobile, and this 75% rang true for both, and it totaled about 2.5 megabytes in images. Now, when this customer approached us, they were looking to improve performance of their site. And like many e-commerce sites in their situation, they wanted to focus on images, because when you see that 3/4 of your traffic is going to images, it seems like the most obvious case for some low-hanging fruit optimization. And to some degree, that's true. You can definitely save a lot more bytes by reducing image size than anything else. But as you'll see throughout this webinar, this doesn't necessarily mean that pages get faster and the user experiences improve. There are some other factors which can play an even bigger part into how pages render and how users experience your applications.
Thanks, Simon. So let's take a look at a typical image on the homepage of this website. This is part of the main carousel, along with 3 or 4 very similar kind of style and size. We started by optimizing these images, and the first thing we did was look at the format of the image. So we started off with a JPEG image for this, and we converted it for WebP. Now, if we were using a browser like Edge or Safari, we might use a JPEG 2000 or a JPEG XR. For this example, the WebP, we managed to shave off 26% of the bytes just by changing the format alone. So this was a good start. The next thing we want to do when we optimize images is to pick the right quality. Now, picking the right quality can be hard. If you overcompress your image and reduce the quality too much, then your pictures are become pixelated and grainy. If you choose to keep them as a high quality, then the chances are they're going to be large and then slow. So what we do at Akamai is we use something called perceptual quality, to use a computer to basically make that decision for us, make the image as small as possible without reducing the visual quality. When we applied it to this single image, we managed to reduce this image by 61%. We also applied optimizations to make sure the images were the correct size for different device types as well. Now, this is just one image. It's a pretty impressive return for one image, but we also want to know how much of an impact did optimizing the images have across all of the images on every single page. The answer to this was 56%. We managed to shave off this many bytes by resizing, changing the quality, and changing the format to the appropriate browser-specific format. Now, 56% for this customer equated to a saving of about 70 terabytes over the course of 1 month. And that's huge. 70 terabytes is a direct cost saving in CDN bandwidth, in cloud-based bandwidth if you're hosting in AWS or Azure. It wasn't just the whole site that achieved 56%. Obviously, that varied by page group. If we look at things like the homepage, we saw about a 40% reduction, the product listing page as high as 80%, and on the product pages themselves, about 50% reductions.
And that makes a lot of sense when you think about it. Home pages tend to have those big banner images with lots of text, which are really hard to compress. And product listing pages have lots of smaller product images, which can be compressed really well in JPEG and WebP formats. So let's take the homepage, that 40% improvement, and put it through a synthetic testing tool. If you haven't used webpagetest.org before, I highly recommend it. It's a free and open source synthetic testing tool which uses real browsers to show you how your pages render to your customers. Now, in this case, we were looking at a desktop at a cable 5 megabit per second connection, and the results were that by saving 40% off the bytes, we rendered images up to a second quicker in this test case. And this is kind of where most of these optimization studies end. We have optimized the images, we've shaved off millions of bytes, and we've shown that the performance improves in lab conditions under synthetic tests.
So thank you all for listening. Great webinar. But Simon, what you haven't done, you haven't told us about the real user data. How did that look?
Now, I kind of wish you hadn't asked me that because it's a tricky one. So when we looked at this customer's data before the image optimizations, we saw that the average median page load time was 2.85 seconds. Great number. And when we optimized these images and saved them 70 terabytes a month, the result was 2.85 seconds. Not quite as impressive as we may have hoped.
No, I don't think that was. But what it does do is it gives us a great segue into our next section, Simon, and that is the challenges with real user data. So what problems do we see with real user data? As human beings, we like things to be simple. And having one single metric which represents performance across our whole site is really easy. It's easy for people to understand. It's easy for us to share. But what it doesn't do is it doesn't give us the insight into the experiences that individual users are having. So if we take this website from this customer as an example, they have 3 different breakpoints. That means there's 3 different versions of their site. Now, specifically in part of this case study, we're looking at the percentage savings or the byte savings or the performance changes of images. And if you look at those different breakpoints, the imagery can change dramatically within them. There's other things that affect performance as well that one single number will never give you. And that's things like the devices people are using, the locations they're coming from, or even the browsers. All of these inputs impact performance, and a single metric doesn't cover them. So our first bit of advice today is to make sure when you're using real user data is that you break your data down by common device types and common and popular page groups. It makes perfect sense that for an e-commerce website trading today, that the most popular device types are desktop and mobile, and the most common pages are the home page, the product listing page, and the products page. If we look at the data now while we've broken these down, we do see some benefit. If we look at the home page on desktop, we see we save about 68% in bytes, and we improve the performance by 70 milliseconds, which is about 2.3%. Perfect. So that's a good way of breaking the data down. We see similar things on mobile. If we go down to the product listing page, again, we see massive byte savings here, 75% on desktop, but strangely now we see absolutely no change in performance. On mobile, slightly different story, but the difference in performance is small. If we go to product page, we see some pretty good byte savings, but now we see no performance change at all. If anything, things may have got worse. And this is interesting. There's 2 very clear takeaways from this data. The first one is that just because you're saving over 70% of bytes doesn't mean to say you're going to see that reflected in the page load time. And the second thing I take away from this is there's something probably wrong with our product page. You might want to think about having a deep dive on that.
Yeah, and as performance consultants, these counterintuitive numbers tend to highlight something strange going on with the website architecture. And it's a great place to start digging in to see how the page is architected and see what's causing these interesting results. So for our next section, we want to do a bit of a deep dive on the product page. And this will serve 2 purposes. One, to highlight some of the best practices in measuring the business impact of improving image performance, but also to take you through the case study and how we worked out with this customer what was happening with their web pages. So we want to talk about, most importantly, I think, making sure that we're testing these things correctly, making sure that we're comparing 2 variants of the site in an accurate and consistent manner. Once we're happy with that, we want to make sure we're looking at the actual bytes delivered to devices. It's all very well looking at lab conditions and seeing that images get 60% smaller. What we need to do is make sure that they're actually getting to devices smaller, ones with all sorts of strange and wonderful user agent strings, which may throw these optimizations off whack. We also then want to make sure that if we're making images smaller, that's reflected in the network, that we're delivering images faster. Things like changing file formats may break some caching rules at your CDN, which may mean that we're not delivering images as quickly as we could be. So once we're happy that the images are being delivered fast and small, we need to make sure that they're rendering fast, or at least that we have a way of correctly and accurately measuring when those images render, so we can see the benefits. And then making sure we're loading the images in a safe way, loading images in a way that makes sense for browsers and gives them the opportunity to render them fast to a user. Once we're happy with all of that, we can take these metrics that we've got of accurate image rendering, accurate image performance improvements, and correlate that back to business KPIs, making sure that we understand how improving images relates to bounce rates, session lengths, conversion rates, and basket values.
Great. Thanks, Simon. So let's dig into these in a little bit more detail. Let's start with A/B testing. This is the first thing that I do when someone comes to our team with any kind of escalation is, does A match B? Is it a fair test? And I think when it comes to A/B testing, you have 2 choices. The first is to split the traffic and take a measurement of A and B during the same time period. The second one, in this example, would be to have a measurement for 1 week of unoptimized images, and then you take the same measurements in a second week of the optimized images. Now, the big problem we have here is highlighted by these graphics. If we look at the homepage of this website in April, there's one image that is about Easter. If we look at it in November, there's a second image and it's about Black Friday. Now, this is an extreme example. I'm hoping you wouldn't do your testing over the course of 6 months, but retail sites, especially fashion-based ones, will be changing their offers nearly every day on their homepage. And it's important that if you are going to do this approach of testing over time with an on versus off period, you need to make sure everything stays the same. And if you can't, then your results are basically going to be inaccurate. So the good news here is that the customer we were working with was doing a proper split test. So the first thing we checked off our list to make sure it was okay was the A/B test, and we got a green tick in this box.
So the next thing we need to look at is the numbers we're using to represent page performance. So you spoke about 2.85 seconds before, and what we used to get that number was the median page load time. Medians are great because they summarize a distribution into a single number. And as Michael said earlier, humans are simple creatures and we like simple numbers. The challenge with that is that it kind of hides the distribution underneath. So we know that 50% of experiences were faster than 2.85. We know that 50% were slower, but we don't know how many people actually got to an experience of 2.85 seconds and whether that's meaningful in any way and what the distribution looks like behind that number. Ideally, we'd look at the distributions and understand how the histograms represent the distribution of user experiences across the site. But of course, these are harder to compare and harder to share as a single number across a business. So we've used a simple performance banding method for this customer, where we look at experiences sub 3 seconds as good, greater than 5 seconds as poor, and in between 3 and 5 seconds as an intermediate experience.
And Simon, tell me, how did you actually arrive at those bandings?
So the bandings are unique per customer. You can't say that for every site that 3 seconds is your good band. What we did was looked at the correlation of performance with key business metrics like session length and exit rate, and worked out that for this customer, anything below 3 seconds resulted in pretty consistent business performance. Greater than 5 seconds resulted in continuing decline in results. And between 3 and 5 seconds was a bit of a plateau. So a safe zone for a slower experience.
Okay, great. So let's apply this banding then to the pages and the device types that we were looking at before. First thing we see on the homepage is pretty positive results, especially on mobile. We see 3.5% less users, or more users rather, getting a good performance, and we see 2% of users, or less users, getting a bad performance. So this kind of reflects what we were seeing in the median as well.
Yeah, we're shifting people from the long tail, the poor experience, and shifting them into our good experience band.
Perfect. When we move to the product listing page, again, this is a pretty positive view, but it's not as positive as the homepage, which kind of reflects, again, what we saw in the median numbers as well.
Yeah.
And when we go to the product page, oh dear, we're seeing exactly what we saw before in the median. We're actually seeing performance getting to some degree worse, and on mobile is pretty close. Now, on one hand, this is disappointing. On the other hand, this is just confirming what the median was telling us, and actually there does seem to be some kind of genuine issue that causes no benefit to page load time on a site that has optimized images.
So in our performance analysis, we said that the product page had a reduction in image bytes of around 60%. Now, before we go into any more detail, it's probably worth going into or investigating where that number comes from. So we collect our image size data from real user monitoring using Akamai's mPulse. And a really important side note here is that this customer was loading their images from a CDN domain. It wasn't off their origin domain. And the only way we can collect size data is if those responses come with a timing allow origin header, something that you can configure at the CDN level or using the image delivery product of your choice. So once we have this data, we can collect it with the resource timing API, something that's available in almost all browsers, even mobile browsers, and beacon that data back for analysis. Now, it's worth noting that there's two size metrics that we get back with resource timing. One is the transfer size, and the other is the decode size. Specifically for images, these can be the difference between the two can be really important. So in terms of what happens when a customer loads a page, so the first time a customer loads a page, they will transfer 500 kilobytes of image data, and there'll be 500 kilobytes of image data decoded to render it on the page. If that user refreshes the page, they don't need to download the image again because it's cached in the browser, but the decode size is still 500 kilobytes. Say they navigate around and come back to that page, again, the transfer size is 0. Now, another user who's visiting the mobile version of the site will have a smaller image with a transfer size of 100 and the decode size the same. And again, if they reload the page, the transfer size will become 0. Now, in this really simple example, let's try to work out the median values for each. So we sort by size and pick somewhere in the middle, which gives us a median transfer size of 0 and a median decode size of 500. Obviously, this is a contrived example, but it shows the potential issues when you're using either transfer size or decode size. So transfer size can be watered down significantly by the effect of browser caching, which doesn't necessarily reflect the performance of the images that we're delivering over the network. So in most of this, we're going to be using the decode size to represent the performance improvements that we've achieved.
I think it's also important there, Simon, though, that we've already mentioned that you need to split by device type, because this decode size has given us the 500 kilobytes, which is the desktop version, not the mobile. So really ramming home that message there that you've got to split by device types, otherwise this is going to go wrong. So that said, when we think about optimizing images, we do it for two reasons. One is to make them appear faster on the network. And when we're considering this metric, we do have to consider the impact of what Simon's just talked about there around the transfer size. Because if you're not going out to the network for those images, if they already exist in the browser, you're going to have a lot of zeros. And that's going to mean that the delta between your optimized and your non-optimized version becomes a lot smaller and, as Simon said, watered down. That said, on those occasions when we do want to go out to the network, making the images as small as possible and as cacheable as possible is going to give us the best result. The second reason we optimize images is to make sure they appear faster in the browser. There was a talk about a year ago from Tim Kadlec, which talked about mobile image processing, which is a really good talk. I recommend you look up on YouTube. In that talk, he talked about the footprint that an image leaves on a low-powered device in terms of CPU usage and memory usage. And actually, just by making the image the right size and only serving the bytes that you need can have a dramatic impact in how long it takes a browser to just interpret that information and display it to your end user. So let's have a look at some of the ways in which we can measure the network performance of images. The first one is pretty straightforward. We can use resource timing. Resource timing is a browser-based API which will give us the start and end time of an image downloading over the internet. It's pretty straightforward to set up in a tool like MPOS. You would just specify the URL of the image you want to measure, and that would be available straight away in any of the dashboards that you wanted to go and analyze. Now that's great. That's for one URL. Now, the problem we have with the page we're looking at here is we're looking at product pages. Now, what I would like to see is data from all product pages, not just one. And I certainly don't want to have to go and add 5,000 URLs to pick up individual data. So we can do that by using CSS classes, and more importantly, CSS selectors. So we have the ability for the beacon in MPOS to be able to be configured to a CSS selector. So for example, if you have a product page that has a product image which has the class product, and within there's a div wrapper and then the image itself, we can specify this in MPOS, and now we can go and get under the same metric the performance of every single product image on all the product pages. The other area you might want to look at with network measurements is the collection of all of the images from your image domain. So this is taking the timer of the first image to start loading all the way through to the end of the last image to load. And you would hope to see some bigger differences here between your optimized images and your non-optimized images. Again, if we look at how you do this in mPulse, we use our CSS selectors again, and this time we can specify just all images from a certain domain. Let's take a quick look at what this will look like in a waterfall. So with resource timing, we would be looking at the start and end time of a single image. This image displayed here around 1.5 seconds. Remember, this is just for one individual URL. By looking at CSS selectors, we can then open this up to a different class of image, whether it be a product image or a hero image. So same timing information, but a much wider scope. And finally, if we look at the resource group, then we're looking at the very beginning of loading those images all the way to the very end of loading those images. And as I mentioned earlier, the goal here would you would see a lot smaller time in your optimized images to those that are not. Now, we haven't got the specific before and after data, but I can confirm that when we looked at all of these raw image network metrics, we were seeing a positive improvement. So we could tick the box that our network performance for our optimized images was positive on this product page.
Which takes us to measuring visual performance. So there's been a lot of discussion and heated debate in the performance community over the past few years as to what's the best metric to use to measure performance. And the result tends to be, it depends, the most frustrating answer. But for this client, we wanted to have a quick look to summarize how the standard performance metrics relate to what's rendering in front of their customer. So if we take a film strip view of the product page, we can see on the left-hand side, we've got a blank screen, so someone just getting to the page. On the right-hand side, we have the complete page. Now, interestingly, the first metric on the left-hand side here is DOM complete, which we often see after the first render. Now, this customer has JavaScript delaying the render of the page, which means DOM complete comes before the render and is not a good metric to measure performance of the page for obvious reasons. Now we move on to page load, which is probably the most popular historical performance metric, and it's still the default for most page performance measuring tools. And at this point, this page structure is loaded, and a few images have loaded, but the key thing that we care about on this page, the product, has not rendered to the user. Moving on, we've got the page complete event. So this is when all the resources have finished loading. This is something that's really hard to measure in RUM because we want to send the beacon, send the data back as soon as possible. So we don't wait for everything to finish. And somewhere in the middle, the image was loaded. Now we looked at some of the newer the newer metrics that we get from browsers, and time to interactive, that first time when the JavaScript execution has slowed down enough that a customer might be able to interact with the page. This seemed to correlate pretty well with that image loading, but it doesn't give us a secure metric to consistently measure when that image renders. So we need to look a little bit deeper. And when we looked at the web page waterfall for this page, we saw that the image was actually loaded on the network really early, about a second into the page, at which point the whole page was blank. Now, not 2, but 3 seconds later, the image was rendered in front of the user. So there's a 3-second gap between the image loading on the page and the image rendering on the page, which obviously means that although the resource timing measurements are fantastic for measuring the network performance, how fast we can deliver those images, it doesn't help us measure when those images are rendered to the customer, which is actually what we care about from a user experience perspective. So we need to do something a little bit better. And the best way to do this is to use the user timing API. So what we care about is when that image is rendered. And the user timing API gives us a method of setting performance marks and measures, which can be consumed by most synthetic and real user monitoring tools available in the market, which actually measure things that we care about. We know our sites better than anybody else. We should know our customers better than anybody else. So we can determine what is the most important thing to measure for each page group. On the product page, for this customer, we recommend the product image. And that's the example we've got in front of us is a performance mark based on when the product image is rendered, but also things like when the quantity or price are available on the page. When that JavaScript is executed is something critical because a user can't add to basket until that happens. So it's another performance measurement that we should optimize for.
So we were pretty intrigued by what was causing the issue And so we dug a little bit deeper, and we went down into the Chrome DevTools and had a look at what was causing our images to be delayed in the browser. And what we found was hidden down the bottom of the page was a bunch of JavaScript files that were all running sequentially, which is not good. And within it was some JavaScript that was responsible for loading the product viewer. And by doing this, what the customer was doing was hiding these images from the browser. So when the browser is trying to determine what it needs to download, build its DOM, prioritize the most important things to download, it couldn't find those images because as far as they were concerned, they didn't exist until this JavaScript had run. And we also saw in Chrome DevTools the loaded by, or the initiator column was loaded by a jQuery library. So this is the single biggest bottleneck that these guys are facing today. If they were to fix this issue and make the images discoverable by the browser, then potentially it would solve their problems, or they may run into another bottleneck. The other bottleneck they may run into would be the HTTP2 prioritization. Right now, there's a lot being written around the fact that a lot of server implementations of H2 don't prioritize resources in the correct way. So while at the moment they're lazy loading all of their images, our advice would certainly be to continue maybe lazy loading the secondary product images, but for the first product image on the page, they really need to start thinking about making this available to the browser earlier. So when we scratched our head and before we went back to the customer, we kind of needed a way to explain this. And our way of explaining this to the customer is that right now, you've optimized your images to be a racing car, but you're driving it home down the highway in rush hour. Doesn't matter how fast you make that image, it's not going to load any faster, all the while you're loading it via JavaScript. So when we want to move away from loading our critical images with JavaScript, we look towards native responsive images. There's two available solutions today. The first one is source set and sizes, and there's a small code snippet here. The second one is the picture element, and again, a small code snippet here. Now, this is great. It gives us the ability to control different size images, different format images that we want to load. However, it becomes hard to do. Writing the code becomes hard. The logic has to go into the HTML. You also need to create those images up front. So if you want to avoid that, because that is a complex task, then you really want to be looking at a tool that will help simplify this markup, but also help you in the creation of those images as well.
That said, we did see some performance gains. We saw on mobile, for example, that the homepage got a tenth of a second faster. And something that we pride ourselves on in Akamai's Impulse is our ability to link performance metrics back to business KPIs, because we know that performance is only important if it makes a difference to your bottom line. So to that end, we correlate performance metrics with business metrics such as bounce rate, session length, session duration, conversion, and basket value. And what we did for this client was take their mobile data for a week and plug in these predicted values to our what-if analysis. And our what-if analysis predicted that approximately £200,000 per week of increased revenue from mobile devices was being left on the table that could be picked up simply by improving the load times, as we had done by optimizing images. And obviously, as we optimize images further and start to free up that highway so we can get those images to the customer quicker, that revenue would increase significantly.
Wow, that's pretty good. Excellent. So we've now managed to walk you through those best practices. We've made sure that we were doing what we were expected in the browser. Now, admittedly, on the product page, we didn't really come up with a solution that's been implemented and we can show you those results, but we've certainly given the best practice advice to the customer. But even without that, we've managed to show there's benefit to the business by optimizing those images. What we wanted to spend the next couple of minutes doing was just give you a few bonus features of RUM that you can do when you're looking at how you measure images on your website. The first one is to think about things like DPR. DPR is the device pixel ratio of a mobile phone, for example. The most common way of thinking about this was with the old iPhones, and then we moved to Retina screens. The traditional iPhone was a 1x screen and a Retina screen was a 2x. Now, this is the data taken from this customer's website. And what we see at the top of this page is the 2x and 3x displays. These graphs are also ordered by the popularity. So the most popular device accessing their pages is a 2x display. Now, we've already mentioned that you may choose to serve responsive images, serving different images to different size devices. But you may also want to include in that different images to different screen densities. And when we start doing that, it means we're serving different byte sizes to different screens. And we need to break our data down by that. Not only do we need to measure the actual byte served, but we should also measure the impact on performance. As we can see from this graph, the top two lines, the 2x and 3x displays, the performance there is pretty good. They get 50% of their users experiencing this good performance under 3 seconds. However, if we go down a little bit, we see these 4x devices hiding down there, where only about 25% of users get a good experience. Now, although we haven't dug into this data, my guess is that the reason this is bad is because we see the 4x display, we decide to serve an image that is 4 times as big, but that doesn't take into account the kind of connection they're on. Maybe they're on the train on a poor mobile connection that isn't going to benefit at all from having a larger image being served to it. And this is, 4 times as many bytes per pixel.
If you search for data saver techniques, one of our architects has recently published a post on the Perf Planet Performance Advent Calendar analysing this exact situation and how you can respond better to DPR headers from your customers' requests. Speaking of headers from customers, there's a header that comes from a couple of mobile browsers, specifically Chrome Mobile and Opera Mini, and it's an opt-in where customers have specifically said that they want to save data. They want to have fewer bytes over the network because perhaps they're on a lower performance device or they're on a capped bandwidth plan, and they want to experience the web fast and without spending too much money on megabytes. This, like I said, is only available really in Chrome Mobile and Opera Mini. And what the charts show us here is that for those devices that send the header, 20% of people have opted in to the data saver. And those experiences tend to be significantly slower than the mobile experiences where the header isn't present. So that's iOS Safari, for example. So iPhones tend to perform better than Android devices. And in this case, the customer overall was getting 5% of mobile users telling them they wanted to save bytes, telling them they wanted a potentially lower quality experience so they could get a faster experience and one that used less of their bandwidth allowance. And this is one of the cheapest bits of user feedback you can get. And what we can do is start to modify the way we deliver our images to these users so they perhaps get a slightly lower quality, but should get a much faster experience.
That's interesting, Simon. And it's interesting there that you've got users who are willing to accept a lower quality image in order to get a better all-round experience. It actually leads us on to our final piece of advice or areas where you could go and analyze, and that's to think about the impact of quality against engagement. Right up the top of this webinar, I think Rob pointed out the most successful websites in the world are those with high-resolution, engaging images. But as we've already discussed, that comes at a cost. Images become slow. So what do? We try and optimize those images. And we do our best to make sure we don't affect the quality too much, but still get a decent performance from those images loading. But what I would encourage you to do is actually run an A/B test against quality of image and use a tool like mPulse to split that data out and look at the effects of the engagement. How does your session length change if you reduce the quality of the image down to a kind of a median level rather than a high level? Can you get away with shaving off more bytes without impacting your business, or are your users very sensitive to that quality? I think in addition to this as well, as a retailer, you could certainly start looking at the return data against the quality of image as well, especially those returns where someone's checked the box that says the article didn't look like the product did online.
And there's definitely going to be a sweet spot somewhere where the balance of performance and engagement and quality gives the best possible return for your business. So that was our last piece of advice. And what I wanted to do before we close up and start questions is summarize those best practices that we've been discussing. So at the beginning, we said optimizing images is easy. It's the kind of the low-hanging fruit. But it turns out that there's a lot of dimensions to optimize for. And it isn't necessarily as simple as turning your JPEG quality down to a lower number. And it's even more difficult when you consider delivering different images to different DPRs. So it's easiest to get a tool to do it for you, of course. Measuring the benefit is surprisingly hard. There are so many different factors that impact the way your images are rendered to your users that measuring a single metric doesn't necessarily give us the results we would expect. So we need to split by major groups: mobile, desktop, DPR, breakpoints, your page groups, countries, connection types. There are a whole slew of dimensions that we should be slicing and dicing our data by in order to get actionable insight into what's happening to our users. We need to use meaningful metrics. And by meaningful, I mean meaningful to your business and your users. So measure things that you can change and measure things that you know impact your user experiences. So when the image renders rather than when the image downloads, for example. Avoid JavaScript in general, but especially for when you're loading images. Critical images should be in the DOM so the browser can find them early and prioritize them as it needs to. Lazy loading or JavaScript injecting images guarantees that they'll render slower. So it's a good idea for below the fold images and perhaps smaller thumbnail images. Be aware of browser behavior. And this is something that's constantly evolving, especially with all the discussion around HTTP2 and the way that both browsers and servers are dealing with prioritization of assets. Every browser deals with prioritization different at the moment, which makes it very difficult to optimize for. So something to watch out for in the future. And finally, correlate everything back to the business. There's no point making all these changes unless you can see the benefit. So it's most important to track these things over time so you can justify making these changes, doing the work, and seeing the impact on business results. And I guess our closing statement is that small gains can make a big difference. We saw a few milliseconds here or there on mobile, but as we apply those changes to real user experiences, we see bigger basket values, higher conversion rates, and more money to pay for more performance gains.
Thanks, Simon. So hopefully we've shown you some techniques here to optimize your images. Hopefully you've got a bit of an understanding how you could deep dive and show the return on investment on that. If you don't, if you're still stuck and you don't see any benefit, I have one bit of advice. I liken optimizing images to eating healthily and exercising. Ultimately, people will embark, especially in January, on a diet and trying to be more healthy. And when they don't see the instant weight loss, they might give up. But that's the wrong thing to do. We know that they should continue to just eat healthily and exercise because it's the right thing to do. And I think that's the same with image optimizations, is even if you can't show the benefit, do it anyway. You know it's the right thing to do. So with that, let's pass back to Rob and see what questions we've got coming in.
Cool. Michael, Simon, thank you very much. Great stuff. I appreciate you sharing that real-world experience. So thank you. We do have a couple questions that came in. Thank you to those who submitted questions. The first one is from Michael, Simon, whoever wants to take this. As you were going through the presentation, you showed great improvements on the homepage stats, but despite saving more bytes on the product listing page, the performance improvements were less. What was the reason for that?
So again, it's kind of stepping back from the data and having a look at the pages themselves. And one of the things we noticed is if you think about a homepage or a product page, it's got a lot of very large images. But there's a few of them, and making them smaller has a lot of benefit in terms of the network and the efficiency in which the browser can deal with that. The bottleneck when you go to a product listing page is actually you may have 40 images to load. Now, just because you're cutting the size of those in half, the browser still has to make a connection for 40 images. It still has to deal with those bytes coming in and displaying those 40 images. So I think in this example, it was just the sheer volume of images and the way they were displayed meant that the benefits of just making images smaller is reduced.
Got it. Cool. We also have a question around JavaScript. So we have somebody who's using JavaScript today to lazy load their images. Should they continue to do that?
It's a really good question. And there's been a lot of advancements in libraries to help us lazy load our images with JavaScript. And I think, like I said at the end, there's nothing wrong with lazy loading images for infinite scroll or for those that are below the fold. So you can prioritize assets that are above the fold, those that are rendered in front of the customer first. So I would never recommend lazy loading or JavaScript loading your critical hero images, your product images. But lazy loading everything else is a good thing to do because it'll free up the browser to do other important things for the above the fold content.
Yeah, and if you are going to lazy load, don't attach it to a scroll event.
Cool. And then another question around image formats. Do you advise using WebP format?
Let me take this one. So, yes, I personally would. So WebP has a lot of benefits in the compression that it uses to make the file size smaller than a JPEG. But where I see the most benefit in WebP is actually converting from a PNG to a WebP, because it gives us the benefit of the transparent background, but also gives us the ability to compress the quality as well. So double benefit on that transformation. What I would say is, if you are thinking of using browser-specific formats, get an automated tool to do it for you. Otherwise, you're going to have to create those versions yourself, and you're going to have to use the picture element in your source code to go and put those images and the selections of when to select each one. And all of a sudden, your picture element become quite unwieldy if you've got different formats for 3 or 4 different browser types, as well as different sizes for screen sizes. Final thing on WebP is it looks like there's going to be support in Firefox and Safari coming soon, or is it Edge? There's definitely 2 browsers adding support, so it looks like it might be a kind of a slightly more universal format anytime soon.
And another final thing on WebP, JPEG support progressive loading, progressive encoding, so you can send lower quality versions and gradually increase the quality, which means you get to render pictures quicker. WebP doesn't support that. It's more like a PNG where it has to send the whole image before you can see it. So if you're relying on progressive images, WebP won't help you there.
Cool. We have time, I think, for 2 more questions. One, we don't have RUM. What's your advice of doing this with synthetic monitoring?
That's a tough one. So I guess the nice thing at the beginning that we said, here's the mic drop moment, is we use synthetic data to validate that things were changing in the way we expected them to. But RUM data gives you that breadth and depth of data which you can't get anywhere else. So if you were testing with synthetic, the best thing you can do is test a lot of pages over a long time and try to cover as many bases as possible with device types and connection types especially. There's no accounting for the variability of connections in the wild. So we would always recommend a RUM solution if it's possible. And there are a lot of RUM vendors out there that offer a free trial or a free version, including nPulse. There's nPulse Lite. So there shouldn't be any reason not to stick a RUM tag on your site, and that would be my recommendation.
Cool. And we did have one last question that came through. How do we make best use of preload prefetch for performance?
So let's break this out then. So let's talk about preload first. I think preloading images is potentially a dangerous thing to do. If you start loading that image before other resources have been discovered and downloaded, you could sap out most of that bandwidth for a large image. So in theory, it's something where you think you could do a good job. Certainly when a user is in a session already and maybe they have your CSS libraries, your JavaScript libraries already in cache, then it could be a good technique. But straight off the bat in an uncached page, I'd be very wary about the size of the image that you're going to preload. Regarding the prefetch stuff, it's a good way of pre-populating images that you think may be needed next. And we talked earlier on about the optimizing images over the network. I think a phrase is that, the fastest request you can make over a network is one that you don't have to make because it's already in cache. So for that side of things, it's great. But we've also shown you today how many users are opting out of getting large amounts of data. And I think with prefetch, what you're going to be doing is speculating on where the customer will go next, downloading data, and if they choose not to go down that path, you could be overloading them with data, and that's going to annoy them. Simon?
Yeah. The most valuable thing out of preload and prefetch is to preload your web fonts, because it's the only thing that browsers won't download in advance. They don't know whether they need web fonts until they see the text render in the DOM. So a link rel preload for a font you know is going to be downloaded is extremely valuable. And like Michael said, if there's a flow on your site and you know people are going to go from one page to the next, then prefetch can be valuable for things like JavaScript assets. Like Michael said, I wouldn't recommend prefetch for images in most cases, unless it's guaranteed to be required on the next navigation. Good question, though.
Great. Well, thanks, guys. We are at time. But Michael, Simon, I want to thank you very much for your time here today, sharing your stories around performance for some of our real users, and I do appreciate your time. And I want to thank everybody for joining. Thank you for the great questions. Hope you found this valuable, learned something, and can implement this on a daily basis. Please do reach out to us if you have any questions or follow up on any of these topics. We'd be more than happy to work with you on that. Thank you. Have a great day.